Hello all, welcome back. So in this today's session we'll try to understand what is the requirement of implementation of the D flip-flop. So other name for the D flip-flop is data flip-flop, or this can also called as the delayed flip-flop. Then one more name is the transparent flip-flop. We'll see later on. So why, right? So these names we referred for the D flip-flop. So now in the previous class we have discussed the SR flip-flop, right? So what is the limitation of SR flip-flop? If you observe, right, so this is the truth table of SR flip-flop, right? So SR, then assumption value, then final output value is the Qn plus 1, right? So these are the input value, this is the output values, right? So 0 0, right? We are considering everything in terms of the 2 times, right? So 1 0 1 0 1 1 1 1. So what are the assumption we can take? Either 0 or 1, 0 or 1 0 or 1 0 1, right? So this condition we called as the no change. What is the meaning of no change? This present state value equal to next state, then it is called as the no change operation. So it means that it is 0 means next state also 0 1 means next state also 1. This is what we called as the no change operation. But if you observe, so what is the meaning of 0 1? So input is 0 1. So which one is activated? Reset is activated. Reset means always output value, whether the assumption value Qn equal to 0 or 1, output value should be 0. This is what we called as the reset operation, right? So now what is the next condition? S equal to 1, R equal to 0. It means that which one is activated? S is activated. 1 means S is activated. So when set is activated, either you are giving assumption value 0 or 1, output value should be always 1. This is what we called as the set condition. But if you observe in previous class, when S equal to 1, R equal to 1, right, both set and resets are activated, right? It means that, so here we are getting the invalid output. Now what is the drawback of the SR flip-flop is that, right, so it is works for the 0 0 0 1 1 0 condition, but the moment input value is 1 1, SR flip-flop cannot able to produce the output value. So it means that we are getting the output value is the invalid value. Right? So what is the point you have to understand here is SR flip-flop is invalid, right? So in which condition SR flip-flop is invalid? When S equal to 1, R equal to 1, by default clock equal to 1. For this condition SR flip-flop is invalid and we cannot use this for the real-time purpose. Right? Now to modify this, right, so I am going to implement something called as the D flip-flop or data flip-flop, delayed flip-flop or transparent flip-flop. Right? So now if you observe here, this what is the circuit diagram? This is the circuit diagram of the SR flip-flop, right? So this is the circuit diagram for the SR flip-flop. Now what is the problem with the SR flip-flop? When S equal to 1, R equal to 1, we cannot able to produce the output value. So for that thing, what we are trying to do is, if no S equal to 1, R equal to 1, if you are not getting this combination, then we can implement the function, right? It means that if you are not getting S equal to 1, R equal to 1, then we will be not finding any problem, right? So the same thing we are going to implement by using something called as the D flip-flop operation. So how we are going to draw the logic circuit diagram for D flip-flop means, this is S value, this is R value, right? So this is D flip-flop means how many inputs we require? Only single input. Now we have S value as well as the R value. So if I connect S value with the inverter or NOT gate operation, so now these two S as well as the R is connected to the single terminal, so that we will be getting the D as the input, so that we will be having the single input value, right? Now if you observe why we connected like this means, right, so we have logic behind this is that in SR flip-flop when S equal to 1, R equal to 1, we are getting the problem, right? So this is the D input right now. Suppose for example if D equal to 0, now what is this value? The same value will you pass to here, right? So now it means S value. What is the S value? 0. The moment this value is passing to here, right, so up to here the value is 0. The moment it passed to the inverter, this value is 1. Now what is the S value? 0. What is the R value? 1. So it means that when S equal to 0, R equal to 1, it is valid or invalid? It is valid condition, right? Now we will try to give what is the possible. If you have single input, either it may be 0 or 1, right? Suppose now this time we will give D equal to 1. Now same value will be passed to here. So here S value will be 1. Then what is R value? Up to here value is 1. Then here it will perform the NOT gate operation, so that 0. Now what is the S value? S value equal to 1, R value equal to 0. Now it is valid condition or invalid condition? This is also valid condition. It means that when you are converting the S value, R value, these two terminal by using of the NOT gate representation, this will become the D or data flip flop. It means that when you pass 1, S value will be 1, R value will be 0. Or one more option is that 0, then it will become 0, it will become 1. It means that there is no possibility of getting S equal to 1, R equal to 1 condition. It means that we can solve the problem of the SR flip flop, right? So this is the modification of the SR flip flop. This can be worked out for only single input. Right now we see that what is the block diagram of the D flip flop means we have the single input, then we have the clock pulse, then outputs are, one is normal output, another one is the complement output, Qn as well as the Qn bar. So this is a circuit diagram for the D flip flop. Just you short the S value, R value by using of the NOT gate, so that it will become the D flip flop. The ultimate aim is that we should not get S equal to 1, R equal to 1. This can be solved by taking circuit something like this, correct? Now next we will see that truth table operation, then finally we will find the what is the characteristic equation for the D flip flop, right? So that operation of the D flip flop will be completed, right? So this is the truth table. So input is single input, right? Outputs are, one is the Qn, another one is the Qn bar is the another output. So suppose for example if you take D equal to 0, now we will pass this value, right? So this is the data or D, right? D equal to 0 means what is the S value? The same value will be passed to here. So here up to this the value will be 0. The moment it passed to here the value will be 1. Now see that what is the value here? 0. What is the value here? 1. So let it be, this is the logic gate 1, logic gate through, logic gate 3 as well logic gate 4. Finally we need to find out Qn as well as the Qn bar value. So here if you see that in logic gate 1 we have the one input value is 0, another input value is what? Clock pulse, right? So what is the clock pulse value? The clock pulse value should be always 1, then only it is called as a flip flop, right? So right. Now according to NAND gate representation, what is the meaning of 0 1? If you don't know, just see the truth table of the NAND gate. So 0 1 means what is the output value? The output value is the 1 for the first logic gate, for this logic gate. Next for the second logic gate, what is the input value? 1 1, right? So 1 1 means according to the truth table, what is the output value? The output value is the 0. It means logic gate 2, the output value is 0. Now question is that finally we need to find out what is the Qn value as well as the Qn bar value. So it means that if you observe either logic gate 3 or logic gate 4, we know that first input terminal value is 1, we don't know second input terminal value. The same way for logic gate 4, we know the first input value is 0, we don't know second input terminal value. It means that by using the single input terminal value, even if you don't know second input terminal value also, we need to find out what? Output of the Qn as well as the Qn bar. So in this case, as we discussed briefly in the previous class, we need to follow this condition. According to the truth table of the NAND gate, if any one of the input is said to be 0, even though if you don't know second input terminal, we can decide the output equal to 1. So if you remember this logic, then we can able to find out the output for the logic gate 3 as well as the logic gate 4. What is the meaning of this one is, if you know one of the input is 0, if you don't know second input terminal value, it means that it's either second input terminal value, either it may be 0 or 1. If you apply 0 also, you will be getting the same output. If you apply 1 also, you will be getting the same output. It means that irrespective of the second input terminal, using the first input terminal, we can decide the output as the 1. Suppose if you ask me, if I take NAND gate one of the input equal to 1, I don't know second terminal, in this case we cannot able to find out the output value, right? It means that if any one of the input equal to 0, we can decide the output equal to 1 without knowing the second input terminal value. Now try to pause the video. For which logic gate we can find the output value? Logic gate 3 or logic gate 4? Right? Yes, the answer is the logic gate 4. If any one of the input equal to 0, directly we can write the output equal to 1. Right? Now if you observe here, logic gate 3, if one of the input equal to 1, Here what is the thing is required? The second terminal is the mandatory. Means if any one of the input equal to 1, we cannot able to find the output value directly. It means that second input terminal value is the mandatory. Now question is that how to get the second input terminal value. The simple thing is that if you observe here, what is the current value? We got 1, right? This is nothing Qn bar, right? So this means that this is the value, right? This is 1, right? It will go to like this loop. Now what is this value? 1. The same value we are writing here as the 1. Now according to the truth table, what is the meaning of 1 1? 1 1 means output is 0. Now see that Qn we got 0, Qn bar we got as the 1. Now it is valid condition or invalid condition? Valid condition. Now you can understand what is the meaning of transparent, delayed or data flip-flop. Now see that what is the value we have passed here? D equal to 0. What is the output value we got? D equal to 0. It means that whatever the data we are sending, the same data we are getting as the output value. That is why it is called as the data flip-flop. Means input equal to output. It means that transparent also, the meaning is that your data input equal to output value. Then what is the meaning of delayed? So see that the moment you are giving D equal to 0, you are not getting the output, right? It means that it is processing by the circuit. After some amount of the time period, you are getting the output, right? It means that it is going to perform some delay operation. After passing the input to the circuit, after some period of the time period, you are getting the same input equal to output value, right? Now if you are getting the condition D equal to 0, what is the output you are getting? D equal to 0. It means that input equal to output means that is called as the D flip-flop or delayed flip-flop or transparent flip-flop. What is the Qn bar value? Just is a complement of this value, right? So 1. Now what we will do is we will take the condition D equal to 1, we will find the output value. Right, so now condition is that D equal to 1. So what is the S value? 1. What is the R value? 0, right? Now what is the clock value? Always 1. So 1 1 means according to the truth table. 1 1 means according to the truth table. What is the value? The value is 0. Right? So 1 0 means what is the answer? The answer is the 1. Now try to identify for which logic gate we can find the output directly. First logic gate or third logic gate or fourth logic gate? The answer is third logic gate. What is the answer? The value is the 1. Now if one of the input terminal equal to 1, second input terminal is mandatory, right? But where to get this value? This value is nothing but this 1, right? Just applying value here 1. So 1 1 means what is the output value? 0. When you are giving D equal to 1, what is the output we are getting? Output also same. This means input equal to output value. What is the Qn bar value? It is just complement of the Qn, right? So this is what we called as the data flip-flop or delayed flip-flop. So this is the simplest form of the truth table. We will be having the one more truth table that is equivalent to this truth table. So what is the meaning of this one is, just I am going to consider D, then one more is the Qn. These I am going to consider as the input values. Now output, what is the value? Output value we are going to consider Qn plus 1 is the output value. So what is the meaning of this one is, so first itself I am going to make this some assumption on the output value. Either it may be 0 or 1. One more possibility is 1 or 0. It means that first itself we are making the assumption of the output, that value we are passing here, so that we are going to estimate the what is the next level of the output value. So this is what we called as the present state assumption. This is what we called as the final output. So for this you don't need to remember this table. If you understand this one, the same thing we can copy it over here. Why we need to write this truth table means when you are converting one flip-flop to the another flip-flop, then this truth table will be helpful. Whatever the truth table operation here, this is also same, but this will be helpful when you are converting one flip-flop to the another flip-flop. Now see that what is the D value? What is the possibility? Either it may be 0 or it may be 1, right? This is a possibility, right? But if you see that what is this output value Q1, right? So what is the assumption we can take? Either 0 or 1. It means that for input 0, we can take the two assumptions. One is 0, another one is the 1. So it means that we are writing the 2 times input. Why we are writing the 2 times input means either it may be 0 or 1 assumption. The same way when D equal to 1, what is the assumption we will be getting? 0 or 1. Now how to write the output value, right? Simple thing. So just come to this truth table. When D equal to 0, what is the output value? 0. When D equal to 1, what is the output value? 1. It means that input equal to output. Now what is the given input value? This one, right? So what is this value? 0, right? The same value, right? What is our input value? 0, right? The same value, right? What is the value? 1, 1. What is the value? 1. It means that your input equal to output value. This is the truth table operation for the D flip-flop. Now what is the final thing is characteristic equation. What do you mean by characteristic equation? If you substitute the value D equal to 0 or D equal to 1, after passing this you will be finding the output value. This is one way to find out the output value. The another way is that we are going to find out the logic expression. The moment you are going to give this D value inside of the logic expression, directly you can find out Qn as well as the Qn bar values, right? So either by using the circuit, by passing the circuit you can find the output value. Then one more thing, by applying the logic expression we can find out the what is the Qn value as well as the Qn bar value, right? So that is what we called as the characteristic equation of the D flip-flop, right? So how to find out the characteristic equation for D flip-flop means from this truth table we are going to find out. So how many outputs we have? Here we have only single output, right? First we will find out the min term. After finding the min terms, that means terms using, we are using the K-map. From the K-map we are going to find out the minimized version of the logic expression, right? So if we see that what is the input value? 0, 1, 2, 3, right? It means that 0, 0, 0, 1 means 1, 1, 0 means 2, 1, 1 means 3, right? Now SOP function, right? SOP means representation of the 1 as the output, right? So where we have the 1 for input 2 as well as the input 3. So what is the min terms we are getting? 2, 3. If you know min terms, right, nothing but the SOP min terms, then we can plot this value inside of the K-map, so then we can find the logic expression, right? That logic expression is nothing but the characteristic equation for the D flip-flop, right? So if you observe here, how many inputs we have? 2 inputs, right? So 2 input means which variable K-map is required? So as many number of input, that variable K-map is required, right? So what is the output value? Qn plus 1, right? So for this we are going to find out the logic expression. So what is the input value? One is D, another one is the Qn, right? This is D, this is Qn. So if you write in terms of here, D bar D, one more is the Qn bar Qn. So inside of the cell, 2 input means these are 4 possibilities. Now what is the min term we got? 2, 3, right? So one is 2, another one is 3, right? So if you know how to perform the right grouping operation, what is the grouping we will be getting, right? So answer is D, right? So what is the expression we got? Qn plus 1 equal to D. What is this? This is the characteristic equation for the D flip-flop. Now suppose for example, see, if D equal to 0 you are taking input. So after passing this circuit you will find the output value, right? Instead of doing this, now what is the D value? We consider D equal to 0, right? So just we will write the D equal to 0, right? So what is the D value? 0. So what is the output value? Output value is Qn plus 1, right? What is the answer? 0. See, if you are giving input equal to 0, what is the output you are getting? 0, right? The same thing if you are applying in the circuit, expression also we are getting the same output. So that is what we call this one as the characteristic equation for the particular flip-flop. In exam point of view, what you have to write is what is the drawback of the SR flip-flop. So when S equal to 1, R equal to 1, this won't work out. So to overcome this, we are implementing something called as the D flip-flop operation, right? So this is how we are going to convert SR flip-flop into D flip-flop. Then finally we need to draw the truth table. This is the another version of the truth table. So from this we need to find out the min terms, then K-map, then finally we need to find out the characteristic equation, nothing but the logic expression for the particular flip-flop, right? So now before going to discuss the next topic, first we will see what is the drawback of the D flip-flop, right? So what is the drawback of the D flip-flop? See that in D flip-flop we have only single input, right? It means that either you can pass the 0 or 1, right? But in case if you want to pass the 2 input value, either it may be 0 0 or 0 1, 1 0 or 1 1, it means that when you have the 2 inputs, right? So when you have the 2 inputs, then D flip-flop will not be useful. It means that D flip-flop can be useful only for the single input condition. This is absolutely okay. But if you have the 2 inputs, right, so then D flip-flop will not be work out, right? So for that we are going to learn something called as the JK flip-flop, right? So in next class we will see how SR flip-flop can be converted in terms of the JK flip-flop, how the problem with SR can be solved by using of the JK flip-flop, right? I hope you understand. Thank you.